All right, so we talked the last time about how growth factors can activate mTOR complex 1 and how that's mediated through this growth factor going through the insulin signaling pathway. But we also suggested that this, in resistance exercise, that mTOR was being activated in a growth factor independent manner. But let's go back and review a couple of things. First thing is that IGF-1 binding to its receptor brings IRS1 and PI3 kinase up to the membrane. PI3 kinase can turn PIP2 into PIP3. That's going to bring AKT or PKB. Sir Philip is going to be mad at me. And PDK1 and PKB are together. PDK1 can phosphorylate AKT or PKB. mTOR complex 2 can phosphorylate the other site. That can activate AKT, which can now phosphorylate TSC2 and move that away from Reb. And it can phosphorylate PRAS40 and move that away from, from mTOR. And now you've got a mostly active mTOR complex 1. You can see there's other components in here that we're going to talk about later. And I've added in this feedback inhibition, where an active mTOR can phosphorylate S6 kinase, which we know is going to be something that's important for some of the downstream effects. And one of the things that does is it feeds back to IRS1 to cause it to be degraded, but it also causes a decrease in the association of IRS1 and P85. So we've got this way that IGF-1 can activate mTOR, and then what happens to shorten this potential growth stimulus is it's got this inherent turn-off switch. So it's basically a time switch where it turns itself off after a specific amount of time, and that time is really short. So it's about 30 minutes to an hour. So after you eat or after you have a stimulus of IGF-1, you get this going for about 30 minutes to an hour. That's not enough to grow muscle protein synthesis, enough to grow muscle mass. All right, so today what we're going to talk about, and in this series of videos that you can watch over a number of days, we're going to talk to those who are still in T Nation believing that testosterone is really important for increasing muscle protein synthesis and degradation and causing muscle to grow. So today, after these lectures, you should be able to state how testosterone increases muscle protein synthesis, describe the effect of testosterone on glucocorticoids, draw the relationship between testosterone, satellite cells, and muscle hypertrophy, discuss the evidence against the role of testosterone in the adaptation to resistance exercise. We're going to give you two examples. One is gender, or sex, actually. It's not gender, it's sex. And then because it's it's a biological construct, not a sociological construct. And then we're going to talk about prostate cancer and those who are treated with anti-androgens and how those two groups, sex and people treated with anti-androgens, are showing us that testosterone is not required for muscle growth or the increase in strength with resistance exercise. You should be able to sketch how resistance exercise can activate mTOR complex 1 in a growth factor, PI3 kinase, and PKB independent manner. And then you should be able to provide evidence that resistance exercise activates mTOR in this growth factor independent way. And you should be able to give the examples of the MKR mice, the stretch examples that I'll give you in these series of lectures, and then the association of IRS1 and P85 after resistance exercise that argues against this, the mTOR being activated by PI3 kinase. And then you should be able to hypothesize as to what controls mTOR activation following resistance exercise.